Hello, my name is Guillermo Duran, and I'm the team lead of the US-Mexico Risk Task Force to support the health supply chain systems for infrastructure and workforce threatened by the COVID-19 pandemic. This is a project supported by the DHS Countering Weapons of Mass Destruction Office and also the DHS Science and Technology Directorate Office of University Programs. Okay, so let's start. So the home security challenge is basically to support the supply chain systems for both infrastructure and workforce by considering the current and emerging regional, social, economic, and environmental risks. So in order to assess the risk, the methodology is basically this formula here, which is risk is equal to hazard by vulnerability by consequences. And I'm going to define each one of these elements. So hazard is basically the probability of a particular threat. We can have an example here of COVID-19 with a given intensity is exceeded within a given period of time. The vulnerability is the probability of reaching a consequence or damage in the element or system of interest. For this project, we are looking at supply chain systems. So that's the reason we have this image here. Conditioned on a given threat intensity could be the COVID-19 in this case. And the consequences are the expected consequence value, could be social or economic, such as people getting ill or economic losses of the element or system of interest exposed to a given threat intensity. Okay, so we have already defined the methodology for risk assessment. So we need to choose a technology here in order to communicate risk to the decision makers. So we opt to adopt the data lake technology in order to communicate risks. And it consists in the following processes. So the first process is the implementation of on-premise, which is the hardware and cloud-based system. And in order to do this, we need to follow some cybersecurity measures that are supported by the IT staff from Texas A&M University. And we also define here a data management plan in order to create an archive data before we start ingesting this data into the data lake. So after defining the curation and archiving process, we can start ingesting data in order to produce risk-based analytics that are going to fulfill the risk-based web platform that we have already developed. And it's also important to notice here that the risk-based web platform was inspired by the previously defined risk assessment framework. Now, in your right-hand side, you have the data lake system diagram, where you have the on-premise system, which is composed by all the hardware necessary to build the data lake. And in the AWS cloud, you have the data warehouse and also the dashboards, the risk dashboards in this case. So now I'm going to describe what is the data ingestion process. So we start by identifying databases such as the Johns Hopkins University database and the CONACYT from Mexico database. We use the Apache NIFI tool in order to ingest the data to the data lake. We call it raw data because it's not structured data. And we use tools such as Apache Spark and Apache Zeppelin in order to create data, to select the data that we want to use or to organize this data as well. And then we move to the data warehouse, which is in the cloud-based component. And we manage this great data using MySQL tool in order to produce the Amazon dashboards that are going to show all the information or all the analytics that we want to show. And these Amazon dashboards are based in Python and PHP. Okay, finally, we have the risk-based web platform, which consists in 3 dashboards. We have the binational dashboard, the Mexico dashboard, and the US dashboard. And for each one of these dashboards, you will have 5 categories. One is the threats, the systems, the impacts, the mitigating strategies, and the state of risk. And also we have here a menu that englobes all the research problems that we are working on, which are the vaccination, the PPE, the healthcare, the auto manufacturing, and corns and fruits. So to conclude this presentation, the web platform has a unique structure based on the risk assessment framework that classifies evidence in terms of threats, systems, impacts, mitigating strategies, and state of risk. And the risk-based analytics are produced to populate this platform to better inform decision makers regarding potential social, economic, and environmental supply chain risks. Thank you very much.